This week before the test, what we're going to be talking about is Coach Book 13 and 14. And this goes along with number 8 and 9 in your notebook, which I'll give you on Tuesday. And we're talking about three-dimensional figures and then running cross-sections through those. That's going to be Coach Book 14. But for right now, we're dealing with three-dimensional figures. And what this question is asking, this is number 1. Ray MP, which is right here, is perpendicular to circle O. And the circle is named by its center. If you translate, which is just a fancy word for slide, the circle along MP, in other words, we're going to take the circle and slide it along here, and in the direction shown by the arrows, in other words, we're going to take it in the direction of this arrow, which solid figure would be formed? What they're asking is basically, if you can imagine a slinky for a second, you're going to expand this guy out, and you're going to keep going like this, and 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 like this. That, to me, and you can kind of take a look at, that looks an awful lot like if you turned it up on its side, it would be a cylinder. So the answer is cylinder. Equilateral triangle PQR is shown below. Line PT, which is the one right down the middle, is the axis of symmetry for the triangle. In other words, everything on this side is exactly the same as it is on that side. If triangle PQR is rotated around PT, in other words, if I could take my fingers right here and spin this real fast, what would that look like? That guy going around and around and around like that. Okay? If it's rotated around P, which describes the three-dimensional figure that will be formed? Well, if I take this and I spin it, it's not going to look, because if you're looking at it from the bottom, imagine if you're standing right here staring straight this way and that thing's spinning. A lot of people say this is going to look like a pyramid. Well, that's not true. It's going to look like a cone. Because if you're staring at it from here and that guy's spinning around, it's going to look like a circle. And as we know, a triangular shape going down with the base of the circle, that is going to be a cone. Number 3. Ray FG is perpendicular to the pentagon shown below. If you translate, which is, again, that word just means slide, the pentagon along FG, in other words, I'm going to take this guy and just move it up this way a little bit. Okay? And forgive my bad artwork. In the direction shown by the arrow, which of these solid figures will be formed? Well, I've taken that guy. Imagine like having a polygon, or excuse me, imagine having a slinky that was in the shape of a pentagon, and just stretching that guy out like this. What is it going to form? Well, it's not going to form that because we're pulling that into a point. That'd be if you were squeezing it into a point. It's not going to look like this either, because this is not even a pentagon. This is a hexagon with 6 sides. Here we have the true answer, which is a pentagon stretched out, and it looks a lot like this. So just imagine, right here you got a small slinky, you stretch that guy out, what's it going to look like? It's going to look a lot like that. In the test, you're going to have several of those. Now, what this question is asking us, number 4, is we've already got a three-dimensional figure. This guy's already been stretched out. What did you start with? The three-dimensional figure, the three-dimensional solid below, is created by translating, which is sliding, a polygon, which is anything with more than 2 sides or 3 or more sides, along that ray. So just imagine for a second if we just had that triangle, that's what they're saying, and then we stretched it or slid it along this ray right here. Which type of polygon was translated through space? In other words, what did we stretch? What type of slinky, for example, would we have had to have stretched across space? And the answer to me is kind of obvious. It looks like we had a triangle there, and we stretched that dude on out there. So the answer is a triangle. Line N divides the rectangle shown below. So this line right here is dividing this guy in half to where we have 2 congruent halves. In other words, this is equal to that. Splitting that guy right in half. If the rectangle is rotated around line N, so in other words, if I pick this guy up and I started spinning it, okay? If you can imagine maybe, for example, this remote control right here, and I started spinning this guy. If you can look at it from here, that looks like it creates a circle, but if we bring it out like that, it looks like it brings or makes something more like, to me, a cylinder. If the rectangle is rotated around line N, which describes a three-dimensional figure that will be formed. So we're spinning that guy. Is it a cylinder with a base of 40 millimeters. Now you might think that that's the case, but remember, we're spinning it right here, not along this way. And the base, even though the base of this rectangle is 40, the base of an actual cylinder, and a good example of that really is kind of this pin, even though it's, I'll find a little bit better of one right here. Okay, the base is right here, not here, but this is the base. So our base is going to be 15 millimeters. And the answer, we have a cone and a cylinder. Be careful, don't confuse cone with cylinder. Okay, a cone is like this, like an ice cream cone. A cylinder is like this guy right here, like a Diet Coke. Okay, so the answer is B, a cylinder with a base of 15 millimeters, which is right here. Here we have to understand exactly what a cube is. A square, as we know, has 4 right angles for sides for the angles, and the height is the same size as the length. Well, in a cube, the height, the depth, and the width are all the same. In other words, we have a cube, and we all know how to draw a cube like so. If it's a true cube, this is 7. This is 7, and this is 7. Okay. The square WXYZ, which is what we have right here, is shown below. It has sides that are 7 centimeters long. So we got that one, that one, that one, and that one. Line segment AC is perpendicular to the square, and we're going to slide that dude up there. Well, we know that if the width and the height is 7, we know that the depth, which is right here, has to be 7 as well. So the question is asking you, if you want to translate or slide the square through space to form a cube, which of the following methods should you use? Well, if I'm going to slide that and create a 3-dimensional figure like so, and make a cube, how long do I have to slide it to make this 7? Well, I know I have to slide it 7 centimeters, but what's the best choice here? Rotate the square alongside line segment AC. Well, I'm not going to rotate it around anything. If I rotated it, I would end up moving it like that. If I reflected it, I would be reflecting it over it. So I'm going to have to translate it, which means a slide. So it's definitely going to be B or C. Well, am I going to have to translate the square along the length of this line segment of AC, or am I going to have to slide it between A and B? A and B or A and C? Well, the obvious answer is going to be 7, because if I move it from here to here, that's going to make that guy 7 by 7 by 14, and by definition, that is not a cube. Number 7, cylinder. A cylinder is sliced by a plane. This is a plane right here. That is perpendicular to the base. In other words, this guy, if you had imagine just for a second, let me grab a Diet Coke can and I'll show you. If you can imagine just for a second, this Coke can. Okay. And I run a piece of paper or something like that right down through the middle of it. I'm going to take this guy right here and run it straight down the middle here, right through the middle, perpendicular to it. What will be the shape of the cross-section? In other words, if I cut that dude in half and I stare straight at it, if I cut this guy in half and stare straight at it, what shape is that going to be? Okay. Well, in this case, it's going to be a rectangle. We're going to be staring straight at it. If we're staring straight at it, it's going to be a rectangle. We have a similar cross-section question. If we run this straight down the middle, a square pyramid. Notice it's not a triangular pyramid. It's not like that. It's a square pyramid. It's sliced by a plane that is parallel to the base. It's very important to remember. That guy is going in there not at an angle, but going straight along with the base. In other words, I would have 2 sheets of paper. This would be the base of the triangle, and if I was staring at this guy sideways, I'd run the other one through like this. So in other words, if I were looking at that guy from the side angle like so, my piece of paper would be going through right there to where these 2 lines are parallel. What will be the shape of the cross section? Okay. Well, that'll be a square. If we do a cross section of any sphere, it's always going to be a circle. That's number 9. What will be the shape formed? We run a cross section of a plane through any point of this, it's going to be a circle. An octagonal prism will be sliced by a plane that is parallel to the base. So if we're looking at this guy sideways, we've got the sides here, I'm going to run a parallel piece of paper through there. What will be the shape of the cross section formed? Well, in this case, we're just simply going to be looking at an octagon. Same thing here. A cube will be cut by a plane that is perpendicular to the base. In other words, it's going to be straight up and down. As shown below, it's going to run right through here. What is the shape of the cross section formed? In other words, if I slice that part off and I turn it around and looked at it, what am I going to be looking at? I'm going to be looking at a rectangle. And finally, number 12, Shelley molded a triangular prism from clay. Shelley will take piano wire and slice through the clay. I don't know if you've ever done that in art class, but that's what we used to do. We used to take a piano wire and slice it right through there to cut it, as shown by the dotted lines below, which shows the shape of the cross-section formed. If she pulls that guy through there, she pulls that rope through there, and then turns it on its side and looks stare straight at it, that's going to be a triangle.